Hello and welcome back for another VMK in the game development series. In this VMK, I'll be showing you how to create more complex objects in the game engine so that you can get the sort of idea of what is required to get complex shapes into the engine as well as be able to render them. So what we're going to do is we're going to create a very simple house which is going to be comprised of 10 vertices. And I'll show you an image in a second of what this house is going to look like. But once we have the sort of structure for the house, we'll set up the framework so that in the game engine we can create an object that is this house, place it somewhere in the scene, move it around, rotate it a bit, and then be able to render it so that we can move in and around the new object. Now, you'll find this helpful just for a pure educational point of view. You'll get a better understanding of what the graphics card is doing, how things are handled in 3D. But before we get into that, I would just like to add that if you do enjoy my videos, you can go to www.maticnose.com and find many more under the download section. And if you want to see additional videos under any specific categories, just let me know, send me an email. If you'd like to support my website, you can do so by clicking on the PayPal icon and donating some money, or you can also support me by clicking on any of the Google ads found on the side. Alright, so let's take a look at this house that we're going to be rendering on the screen. It's going to be like a very simple shaped house like this. It's comprised of a rectangle bottom and then like a triangular gabled roof. If I turn the back hidden lines on, you see here it's a very simple shape. And to make up this shape, there are 10 vertices. There's the vertices that define the rectangular box on the bottom, and then there's the vertices that define the triangle at the top. Now, the way that I've laid out the vertices are shown here. I selected V0, that's vertex 0, to be this bottom left-hand corner one. V1 up here, V2, V3, and V4. So the first 5 vertices define that front face of this house. The next 5 vertices, V5, V6, V7, V8, and V9, back here in the corner, they define the back face of this house. And then with those 10 vertices, we can then define all the faces, the sides, the triangles, the roof. We can define everything using those 10 vertices. The other thing that's important to note here is that the origin of this house, the 0, 0 point, is going to be located at the very bottom in the center here. So when we go and define a width and a height and a depth for this house, it's going to be defined like this. So this is going to be the width. It's going to be the distance from the origin to one side. The depth is going to be defined as from the origin to the front, and the height is going to be from the origin all the way up to the top peak here. Now, to define how high it is from the origin up to this point here, I just use a scaling factor of 0.65, and you'll see that in the code. It'll come up. So keep an eye on how these vertices are outlined, because it's very important to remember in which order all these vertices are and where they're located in 3D space. This is very important whenever we go and start rendering, because again, we've turned backface culling on, which means if we define these vertices in the wrong order, our faces won't show up properly. So it's very important to make sure you define them in the proper order. And again, the proper order is in counterclockwise winding. So as you see here, if I were to define this front face here, I'd go V0, V1, V2, V3, V4, because that's counterclockwise. If I defined it this way, V0, V4, V3, V2, V1, that would be in the clockwise order, and that face would be then invisible. Okay, so now that you know what the house looks like that we're going to be working with, let's just close this off. And now we can go and write the code to actually construct that house. So to do that, what we're going to do is we're going to add a CPP file and a .h file here. We're going to create a class, and the class is going to be house, and all that the class is going to do is define our 10 vertices for us. And the way it's going to define it is based on a couple parameters input that we're going to give to the class. So let's go ahead and start and create the CPP in .h file. Now we're going to put the CPP in .h file into the scene directory. So I'm just going to go into there and we're going to call it house. Okay, let's move this to the proper location and this one into here. Okay, let's start with the .h file. Okay, so the house needs the air handler as well as triangle.h. Now the reason why we need triangle.h is because we're going to be using color OpenGL here, so and that happens to be defined in triangle.h. As well as we're using vertex here, which is also included within triangle.h. If we go into triangle, which is under math, we'll see it includes vertex. So that allows us to use both color as well as vertex. So the class definition for house is very simple. We have a constructor and a destructor, and then a couple of member variables. The constructor takes in a vertex value for the position. It takes a floating point value for an angle, and a vertex position for the size. Now, this really, you have to sort of consider what this means, because a vertex is 3 values, and the size really is 3 values as well. So we're kind of cheating here by using a structure that contains 3 values just so that we can pass 3 values in here with one parameter. We could alternatively have 3 floats here, float for width, float for a height, and float for a depth. But just to make things simple, I stored all the size values as a vertex, so then I can say that the x value of the size is the width, the y value is the height, and the z value is the depth. So that's why I use the vertex here for size. Then we have 2 colors. We have a color for the house itself and a color for the roof. Now what this means is the house itself is comprised of that rectangular box and the triangle roof. Well, each of those 2 objects are going to have 2 different colors, so those are the 2 colors that we're going to define here. The member variables we have are the floating point value for the angle, which is this value here that we're going to pass in, a vertex value for the position, that's going to be where the house is going to sit in our 3D space, and then our 2 colors, and there's our 10 vertices that define our house. And again, these are the same 10 vertices that I just previously showed you in that diagram. And that's it for the .h file. So let's go into the CPP file now and start defining this class. Okay, at the top here we include house.h, and then we have our constructor. And in our constructor, we're just setting a bunch of values. So the position that gets passed into us just gets saved as the position. Our angle gets saved with the angle. And then we have a bunch of definitions here for all of our 10 vertices. Now, let's just take a look at these in a little detail to see whether this makes sense. Okay, vertex 0, this was the bottom left-hand corner of the house on the front side. So what we're doing here is we're saying move in the x direction by a negative value, so we're moving to the left, 0 in the y direction, which means we don't move up, and then we move forward in the z direction by the z value of size. So again, size contains the width, the height, and the depth of our house, as defined in a previous diagram which I showed you. So we see here we're using each of the components, the x, the y, and the z, to define all 10 vertices. And here we see there's that 0.65 scaling factor that I was telling you about to define the points that sort of are along the perimeter of the roof. The full peak of the roof is the full height of the house. However, the roof goes up to 0.65 units from the ground. So there's the definitions for all our 10 vertices. And then at the bottom here, we also save the two colors which are passed to us. The destructor doesn't do anything, so it's just an empty function. Okay, well, let's now add our house to our scene in our world. So to do that, let's go into our scene class, and what we need to do is first go into the .h here, and we're going to add 3 houses to the scene. So I'm just going to make 3 variables here, and they're all pointers to a house. Call it house 1, house 2, and house 3. Since we're adding these in here, we also need to go up to the top here and include house.h. And now we can go into the scene.cpp file to start modifying some of these other functions to include the house. So let's start off with the constructor. And what we need to do here is initialize everything to null, like this. And then in our destructor, well, I guess it's our clean, we need to clean up our house. So we just need to do that. And then in our initialization, we can go and define where we want our 3 houses to be located. Now, what we have here right now are the one big triangle here for the ground. Let's leave that. And then we have all these other triangles. Well, let's just comment these out since we don't want to render them with the houses for now. So I'm just going to take them out. And in their place, let's add the initializations for the house. Now, just for illustration purposes, what I've done is I've created 3 different colored houses with 3 different colored roofs, just so you can get an appreciation for what needs to get done. So first I create this OpenGL color code. This is sort of a gray color, and then we have a color here for the house. We create this pointer using the new operator, and we pass it some values. So remember, we pass in, the first parameter that we pass in is the position, the next parameters are angle, then our size, then our color for the house, and the color for the roof. So we see color for the house, color for the roof are defined up above, and we also have the size here of our house. So we're saying the width of the house is going to be 0.5. So in other words, the full width of the house is going to be 1 because it's 2 times this. The height of the house is 0.7, and the depth of the house is 0.75, which is actually 2 times that. I chose to rotate this house 45 degrees about the y-axis so that it just has a little bit of rotation. And I placed the house at this coordinate, so 1 unit in the x and then -5 units back so we can see it. And again, we do this little error checking to make sure that this pointer actually initialized correctly. Then I repeat the process again for the second house. I just put it into a little bit of different location, rotate it a little bit differently, and the size, looks like I use the same size for all my houses, but we can change that if you want. And then the third house here, again, I just changed the color codes for the house and the roof, give it a new position, a new rotation, and so on. So that initializes our houses. Okay, let's save this and just see if we can build everything. I think everything should be okay. Yep. Now the last thing we need to do is go and modify the OpenGL code, since actually whenever we update the scene, we also need to go and update the house. So here we can remove all this stuff here because this was rendering the triangles, which we don't have anymore, and we can add in the code to render our house. Now to render the house, it's as easy as calling a render function. However, this render function doesn't exist yet because we're passing in a pointer to a house, so we need to write this function for us. So let's go ahead and do that now. We'll go into the OpenGL class, and under render we need to create a new function. It's going to return a Boolean value, and it's just going to take a pointer to a house. Now, since up here we're going to be using house, we need to go and include house.h at the top. Okay, and now we can go write the code for the house rendering. First thing we do is we check to make sure that the pointer for the house is valid. If it's null, then we return false automatically. Which reminds me, in the render function for the triangle, we should do the same check. So if try equals null, just return false. This makes sure that we just don't render things that are invalid. Okay, then what we do is we go and push the current model view matrix value onto a stack, and that's what this function here does. Now, the way that this works, if we go back to the render pre, let's take a look here. We see that up here we create a model view matrix and we set it to the identity matrix. So initially everything's just located at the home position. Then we define the model view matrix by rotating the camera based on your camera position, and we move the camera based on the location it is in. After that, we have the model view matrix already defined for us. Well, now what we're doing in the render function is we're taking that model view matrix and we're storing it onto the stack. And the reason why we do this is because the next couple function calls here are going to adjust the value of the model view matrix. But we don't want to adjust the value of that matrix permanently. So after we're done this function, at the very bottom we call glpop matrix, and that returns the previous value for the model view matrix. So in other words, the value of the model view matrix on the way in is equal to the same value on the way out. So whatever changes we make in here for the model view matrix don't get reflected on the outside of this function. This is important because it allows our code to be modular and allows us to manipulate objects in 3D. Okay, so now that we have the model view matrix stored on the stack, we then go and translate it by the position of the house. So we take the X, the Y, the Z, and we translate the model view matrix. And then after we translate, we go and rotate the house along the Y-axis by the value stored in the class as well. Once we were located in the correct position in the 3D scene, we then go and get the color of the roof, and then we go and render the front side of the roof. So this is the triangle. So the way it's defined is we go and we begin a polygon and we just define 3 vertices here that are in a plane. And here we see, this is where it's important. If you go back to the diagram of our house with the vertices labeled, you'll see that I'm rendering these in the counterclockwise order. So here's vertex 2, vertex 3, vertex 4. Then we render the back of the house, so this is the other triangle, so vertex 7, 9, and 8. And then the right side of the roof, this is the rectangular section, so we have vertex 2, 7, 8, and 3. And then the left side of the roof, 9, 4, 3, and 8. After that, then we only are left with having to render the bottom section, which is the big rectangle. So before we go and render that, we change the color to be the house color. And then we go and render the front side of the house, so vertex 0, 1, 2, and 4. The right side of the house, 1, 6, 7, 2. The back of the house, 6, 5, 9, and 7. And then the left side of the house, 5, 0, 4, and 9. Go through on that diagram of the house, make sure all these vertices here make sense to you. They're all defined in the counterclockwise order. You can see what happens if you reorganize these vertices. If you put them in the wrong order, then you'll either won't see a face at all because you'll be rendering it backwards, or you could accidentally crisscross the vertices, in which case you would see sort of like an X shape on the screen, and that's just telling you that you're rendering things improperly. Okay, and then the last thing we do is we pop the matrix, the model view matrix, back from the stack, so that when we exit this function, we have the original model view matrix. Okay, let's go and try to build this and see if it works. Alright, and then run it. Excellent. So now you see we have these 3 houses on the screen that are rendered for us. We can move around them, and you can see they're rendered correctly. Now, again, if you happen to define those vertices incorrectly for the houses, you would see that some of these faces on the house would not be defined. And as a matter of fact, if I step inside one of these houses, if I just walk right inside, you notice the house disappears. I can't see it anymore. And that's the reason for this is because I'm looking at all the faces of this house from the inside. And it just so happens that all the inside faces are invisible because of the way we've defined all the vertices for the house. All the vertices are defined in such a way that we can only see them from the outside. If you want to be able to go inside of a house, you then have to create a more complex class so that you define walls on the inside of the house that are defined in counterclockwise order. If you do that, then when you go inside, you'll see those walls. So you can imagine this could get very complicated whenever you have 3D objects in a world. Ideally, you don't want to be defining objects in a 3D world by hand. And when I say by hand, I mean you don't want to be writing these classes yourself. The trick is use a 3D modeling package to create your 3D objects. Once you have them created in 3D space, you can color them, textures them, whatever. Export them, and then create a function within your game engine that will be able to load your 3D objects. Once you load them, you can then create classes like these automatically in runtime to be able to extract all the information from those loaded files, and then all you need to do is create the appropriate render functions to be able to render everything properly. And this is something we'll be doing in an advanced course a little bit later on, but just to let you know of how to handle objects in 3D space, this is sort of the process you have to go through. Now, one last thing I wanted to mention, and it's just going to be an introduction to what we're going to do next, and that is, you notice that when I go and run this scene, everything in the scene kind of looks flat. Like you cannot see the edges defined very crisply, and that's because there's no shading. Shading will come in the next tutorial whenever we start adding light sources. Once we have a light source in our scene, it will be able to render things using shading, and when we render things with shading, then we'll be able to see better depth. But right now everything looks very flat because we have no depth cues to tell us, you know, where the edges are and how far things are away from me right now. Okay, so that's that for this tutorial. Come back again next time to take a look at how to start working with lights.